Hello, world! Welcome to the first ever virtual and live Future of Data London Meetup. I am your host, Anna Gillen from Cloudera, and we're back after what I will admit is a long hiatus to dive deep into technical goodies from the big data, cloud, and data streaming world. So whilst this would usually be kind of an evening beer and pizza sort of event where we could chat and get to know each other, I hope you'll still take part in the conversation on the YouTube and LinkedIn comment feeds on the screens you're viewing from. So I guess, why don't you try it out, say hi, tell us where you're from. Maybe you can find that you have a neighbor you can socially distance with and talk about data things, I don't know. So we have a packed agenda for you today. It's an extra special streaming double bill fronted by two of my absolute favorite people from Cloudera's field engineering team. Dan Chafelson will talk us through an operational scenario where he wants to mirror Kafka data in real time across 2.5 clouds. So can't wait for that. And then when you have a really special guest from across the pond, Mr. Tim Span, who will use Apache Flink to analyze weather data in real time and tell us what's going on in the world. So it's going to be techy, it's going to be chatty, and I hope it'll prompt some great questions because after Tim's session, we'll have an opportunity for live Q&A with both of them, which I will host. So ask your questions as we go in the comments, just like we practiced with saying hi. And enthusiastic people who ask questions will be entered into a raffle, which I will draw live on air. And two very, very lucky winners will be in with a chance to win one of these two prize packs. So I've just been reliably informed by my colleagues that I am not actually eligible for the prize myself, so pretty jealous about that. But, one of you can have them. So I'm going to be bringing my colleague and very good friend Dan onto the virtual stage with me. We are not that near each other, but we can still say hello on the screen. Hey, Dan. So Dan is Director of Field Engineering for Data in Motion. He loves long walks on the beach and to tinker with automation and DevOps goodness, and he'll be showing that for us today. And we also got Tim Span, who is dressed very well today in honor of being on a European meetup. And Tim is a principal engineer in Dan's Data in Motion field engineering team, helps customers with complex streaming problems on a daily basis. So hopefully sharing some of his wisdom with you today. Hey guys.
Hey Anna, how's it going?
It's good. Pretty nervous about this live thing, but really happy that you guys could come and share it with me.
We love playing with new technology for the first time live in front of lots of people. It's absolutely the best thing in the world.
It's literally what we do, honestly, every single day. Yep. So yes, it's going to be Dan up first. So Dan, 2.5 clouds. What's half a cloud? Is that like when it's raining a little bit, but it's like a bit sunny and you don't know what to wear?
Yeah, you're not sure what to wear outside. Should it be boots? Should it be flip-flops? Or are you just going to stick the kid on a bike and a Mac and watch him go? I think it's mostly we're looking for puddles here. So no, in this case, we're going to be using 2.5 clouds because I don't have a server in my basement to pretend as my on-prem cluster. So we're going to be putting the on-prem services in one of those clouds. And I think that's about another half a cloud, basically.
Sounds good. Sounds good. So should we get to it? I think, we'll let you cool. Share your screen. Have a go.
Let's do it.
We'll see you in a bit.
Let's look at some nerdy things. Okie dokie. So today we're going to look at a use case which is very similar to one that I've done with quite a few banks here in the UK and elsewhere. And it's a pretty common situation. So we're going to look at a kind of a hybrid cloud architecture that you might end up with in a large enterprise. Let's start with some personas. Let's think about 3 teams in this setup. So the first team, we've got an insights team. They do all of our machine learning work, our analysis for us. And for whatever reason, they prefer to work on AWS, which is not uncommon. Often the first team to build up this stuff in the cloud went to Amazon because they were the first service available. This team also, we've decided, is an external consultancy. So they have a separate security model set up from the company that we work for. So we work for this bank. This is our external consultancy. We don't want them to have access to all our stuff. So they've got a trusted but separate security setup. Our second team is the team who really cares about that stuff. This is our security and audit team. This is the team that's running on my half a cloud. So they're very keen to make sure that any data that's shared between internal and external teams is monitored, checked, that nothing dodgy is in there or no customer information is going to leak and that sort of thing. So they have the right to monitor all teams, and they operate out of their own isolated environment. Our third team is our ever-loving marketing team. They are fantastic. They're always out there trying to push the company public assets and make sure everybody can see them. So they are an internal team to the company. They're fully trusted, but they prefer to work on Azure. Maybe Microsoft made a good deal with that different business unit within the company, and that's where they want their systems to run. Now, this particular setup where your security and audit team are more of an on-prem service, they want to ring fence their environment, have it well protected, and take a copy of everybody else's stuff. That's pretty common. And then where different business units have decided to work on different clouds. We see this a lot in large enterprises with different teams have struck different deals with different discounts. So the situation you end up in, though, is you've got 3 teams and 3 environments with 3 security models, and they all need to be resolved. So let's have a look at how we might do that using Cloudera's CDP. So our 3 teams, the first thing we would do is we get them involved in the CDP control plane. CDP's control plane for public cloud is essentially it's a hybrid console across the cloud services. You can drive it with the API or via the GUI. We're going to do a bit of both today. And it provides all of the baseline things you might need for single sign-on and getting access to the various services, doing infrastructure monitoring or deployment. Got a couple of images here on the left. That's the GUI itself. On the right, that's our published CLI. The CLI is actually a Python instantiation, very similar to the Amazon CLI, which you're probably familiar with if you're a DevOps kind of person like me. And it can be used for all sorts of good stuff like Ansible or direct access and that sort of thing. So we need to get our teams into this control plane. First thing we're going to do for them is we're going to get into enterprise IT, and they are going to go and get the various users hooked into the management console that we were talking about, the CDP control plane. They're basically going to sync up the company ID broker with that environment so that your user account is then available to work within the cloud. They're then going to tie that into what we call SDX, which is our shared data experience. This does all the back-end work and the pieces that you're interested in, so making sure that security models are put in place, data governance is in place, TLS is correctly terminated, all that sort of stuff, right? So we're going to do all of that. We're then, those users who've now got that context in place, they're going to go and make sure that they can deploy the various services that they need. So they're going to have maybe some clusters running different kinds of analysis, or maybe they're going to run some containerized service, like our data warehouse experience or our machine learning experience. And in fact, we're going to have a couple of those up today. So once those users have all of that set up, they're ready to work. And most of this can be done by IT. And in fact, all of it can be automated, which is my favorite thing. I like doing everything in an automatic sort of way, usually using Ansible. So let's go back to our teams. So they're nicely onboarded. They've got access to the various environments and all doing their bits and pieces. What we're going to do is we're then going to give them the cloud services that they prefer. So the marketing team, as we discussed, much more interested in working on Azure. Thank you very much. Our insights team prefers AWS because that's where they've got a bunch of other capability. You know, they've already got the skills to work on that. And for the sake of this example, we're also going to put IT security on AWS. That's just for the deployment I have. Normally, they would be in an on-prem environment, and maybe I'll convince my wife to allow me to put a server in the basement so I can do that next time. Once that's done, we want to give them that SDX and that context we were talking about. So the marketing team, they get their CDP public environment all nicely secured and ready to roll in Azure. The insights team have their own one as well. And then the IT sec team, in order to make this a bit more difficult for me to set up, I've done with a classic Cloudera cluster, which is where we're going to pull down all of their various bits and pieces. Then once we've done all that, all those environments are ready to roll. We're going to give them the actual tools they're going to work on. So let's go and have a look at this. So part of this is a security model that we need to worry about. So it's all very nice. I'm sure you think, oh, doing demos, it's all just great, but you never turn on security because that's too hard. Well, I turned on security and then I automated it because, you know, if you're talking about highly regulated entities and companies, they really do care about this stuff. So in this case, each of these teams has their own SDX environment, and it's giving them their own separate context. What this essentially means is that the control plane, as integrated with their IDP, it's handling authentication and authorization. So it's saying who can talk to what, and in most cases, they can talk to something with just a username and password. What it also has is TLS set up for each environment, and we've set up selective trusts so that data can move between the environments in the manner that we want it to. What we've done, just to keep things simple, is the insights and marketing team have a bidirectional sharing capability. So they've given each other an appropriate certificate to use when they want to talk to each other's environments. IT security have said, you're not accessing my stuff, but I'm going to take all of your stuff. So IT security have nicked off with a copy of the root certificate for each environment so that they can take any data they feel is necessary for their analysis. So we end up with a little model here. So then going back, having a little summary, we've put these users in there, given them their infrastructure, we've set them up with their environments. Those environments have got the security model set up to transfer data between them. And then we've given these teams their services. Now the ITsec team is pretty straightforward. They've just got a simple classic streaming cluster. The marketing and insights team are both running the Cloudera Data Flow service, which provides NiFi and Kafka and friends, various other tools for that. The insights team are also running machine learning and data warehousing capabilities, which we'll go and look at now. So enough of the slides. Let's go and have a look at actually what's in the environment. So for the purposes of this setup, I've logged in as me, and I've added myself to all of the environments. That saves me logging in and out and showing you different users. That would sort of break the flow. What I want to do is show you actually what's going on. So if we look inside Cloudera Data Platform, I'm authenticated as me, as you can see. Go into the management console. I've got access to all sorts of business pieces going on. I'll show you the two main environments first, and then the third one that the ITsec team are using. So I've got a number of environments deployed. The two we care about, this one here on AWS. This is our insights team. So you'll see the DIM prefix that I've used is just to namespace the environments for automated deployment. And then we've got the DIM AZ environment on Azure. This is our marketing team. And these two teams are interacting with each other. And then down here in the classic clusters area, I've also registered just a small environment, which is running our IT security team. So this is this one node cluster here, just a small one to show that you can do it. They're going to be monitoring everything that goes on. So we'll come back to that later. Let's first have a look at what our two different teams are doing. So we hop in here. I think we'll go look at marketing first. So marketing are doing their usual thing out on the interwebs. They've got themselves their environment with their shared context. Everything's running. All the security accesses are showing green. That's great. They've got a data flow cluster running. This data flow cluster is a fairly standard template. It's providing NiFi and Kafka and the Kafka management services around schema and monitoring and messaging and that sort of thing. If we go and look inside their NiFi environment, so this is the marketing team. They've got some odds and ends deployed. They've been playing around some applications and some ideas. You'll note here one thing that I haven't spent a lot of time on yet. This is all single sign-on, it's all pass-through. So I haven't had to authenticate beyond the first time I signed in. It's just passing my credentials through the system and providing me an identity. So it knows who I am here. This is the control plane providing that capability in the background. So then as I work through this, I can use that identity in order to access things, move data around, and that sort of stuff. So a couple of things they've been doing. They've been tracking some COVID data for the business. That's not doing much at the moment. Over here, they've done what is a very traditional thing to test out a new tool. They've made a Twitter application. Everybody loves a good Twitter application. So what they've done is, and for the purposes of what we're doing today, I've been monitoring Twitter for features and pieces around this meetup. So we're monitoring some terms. Now you can see in here inside NiFi, let me just zoom in a little bit. You can see here I'm using a NiFi trick, which is to reference a parameter using the hash curly brace context. Parameters are a way of setting values that you can reuse elsewhere. So here is the parameter context that's applied to my environment. Here's the Twitter terms I'm filtering on. So it's various stuff related to what we're talking about today. I've also got a bunch of other parameters in here I'll explain. So staff list is a list of the Twitter IDs for the team today. See if we're tweeting about the event and filtering those out. I've also got a bunch of information about both the local marketing team's environment and the remote insights team's environment, so I can pass data between them. And this is part of the why this is so easy to work with. So I can set these parameters and I can just pass them around and reuse them. So this points to the Kafka brokers in this environment and the other team's environment, so I can use that to read and write data. The other thing I set up for this environment as part of the context, if I have a look in the controller services here. Oh, wrong controller services, these ones. I've set up an SSL context for both the local marketing and the remote insights team, as well as a schema registry. Now, this provides the environment, the information it needs, and certificate access and that sort of thing, so that we can talk to these various services. It shows me what's using them and what's not using them at a given time. And it really just uses very simple trust stores and key stores. So it's designed to allow you to set this up, so an administrator could set that up and then pass that to an application team to then use it to just do whatever it is they want to do without having to go and worry about complicated security configurations and that sort of thing. So let's have a look in here, see what they're doing. So they're getting those tweets. They're putting those into a raw Kafka topic so that they can reuse them later. They're then fetching those back out of that raw topic. It's a simple pattern that we commonly use with Kafka, where we'll put data into a topic, do a piece of processing, and put it into the next topic, and do these hops so that you end up with more data over time running through different stages. We're then pulling the tweets apart to find the bits and pieces that we're interested in, and we're passing them and we're publishing them down to Kafka. So if we have a look at what we've got here, we can look at our data provenance, what data is passed through. We can have a look at the kind of data that we're sending out at the moment. We can see that we've grabbed some tweets on these topics, and I'm going to hope that there is no swearing in this one, because that often happens with Twitter, doesn't it? And somebody has used one of our keywords, and then it's passed on again. So that's being passed down into our Kafka system. Now, one of the other things I did earlier is I set a filter to see if it would find any tweets which were actually by us about this topic, because we've been saying, hey, we're going to have this event, and off we go. And here I'm using another simple NiFi trick. I'm saying here, if this property, which is the staff list that we looked at earlier with the names of our Twitter IDs, contains the screen name of the person who sent the tweet, then send it off down to this relationship. So this way, my marketing team is looking for tweets from staff within the company to see, hey, what are we saying about the product, and is that a good thing or not? And so we can see here, if I have a look at this queue, got a couple of tweets in here that I sent earlier about what we're up to today. If we go have a look at this, it's going to be very similar. So we're looking forward to chatting about the automation today. It's from me, and it's matched my screen name, so it's pulled it out. So it's very straightforward sort of piece of just simple data passing to do. What that's also done is that's sending that to another Kafka topic, which is going to share it across to my insights team. So let me throw some more, throw that message through a few times just so we can watch what happens. There we go. Just replaying that using a simple NiFi trick. NiFi is a live edit service, so you can easily drag and drop stuff and move things around. So what I've done is I've just got that to replay that tweet a few times. You can see it sent it 6 times into a shared topic here. Now let's go have a look at those topics. So we can go back to our CDP environment. Instead of NiFi this time, let's go into Streams Messaging Manager, which is our Kafka monitoring service on our marketing team's cluster. And they've got all sorts of topics running here. Let's have a look at our topics about tweets. So they've got a few here that they've done. So they've shared tweets out to the insights team. That's the one we're looking at. There's also that raw tweets team they did earlier, and some other stuff, some other applications I was working on. So this shared tweets for insights, this is set up, and shared is a keyword that I've set up in the system so that it makes it available for another team to pick up and use that data set. So essentially what marketing has done is they've gone, great, I've made a I've made a little app here that grabs tweets about this event. It routes them through Kafka, then prepares a nice message. And if it is a tweet from one of our staff, it pops it here into this topic ready for somebody else to work with. Pretty straightforward, right? Cool. So let's go look at what our insights team are doing with that. So the marketing team has reached out to the insights team and said, hey, you guys have got like some sentiment monitoring stuff, right? Could you check that the tweets that our staff are sending out are not like negative about the product or the company or something? That would be great. And I realize that's a completely contrived example, but isn't it how we always do demos? So let's have a look here. So we've got our, that was our Azure environment. We can now go look at our, let me go into this view. This view's a little bit tidier. We now go into our insights team, which is the Amazon environment. So let's go and have a look over there. They've got a little bit more stuff running, as I said. They've got a data flow. They've got machine learning. They've got data warehousing and that sort of thing. Let's have a little look at what they're running in the data flow first, because we're already familiar with that. And then we'll go have a look at what the machine learning system is doing. So they have also got a similar setup. So if we look at NiFi here, they're going to have their own applications running, separate to our other team. Again, this is a completely different environment. This one's on Amazon instead of Azure, but it's just passing through my credentials from the control plane. And literally with like 2 clicks there, I've just completely switched provider of platform, but I still get this consistent experience, right? It's got a couple of different tools here. They're running their own sentiment analysis testing against their model, but they've set up a little application here to score sentiment for marketing. Let's go have a look at that. So here's another little NiFi application. This one's slightly longer. So it consumes Kafka. Now, this is where things get interesting. So you will remember the parameter contexts I talked about earlier. This one is pointing at the other team's cluster. So it's got the same parameter set up. It knows what the marketing Kafka brokers are and where they are and that sort of thing. And instead of pointing to the local insights team environment, they're actually pointing to the other team's Kafka environment. They're authenticating. In this case, I'm using my user account, but I could be using a machine user or a restricted account. They're using the SSL context for that environment, and they're picking up that topic of shared tweets and pulling it in so they can work on it. So with just 2 or 3 properties being set here, we can read in tweets from Kafka on the opposite cluster, on the other provider's environment. We'll wait for those to come through, and then we can work on them, and then we can send them back again. So all of this can be set up by the administrator or the operations team in the background and provided to the team who wants to use it without having to understand how to do all of the cloud security engineering and everything else. So there's our tweets. The 6 that we sent before just popped in, ready to go. Then if we step through this process, what it's going to do is it's going to extract the quote that needs to be sentiment checked. It's going to make sure that it's not empty. It's then going to prepare the JSON that our model endpoint requires. And then it'll invoke the model to go and get the information. Now, I'm going to pause at this point. Let's actually go and have a look at what it's doing, because it's using another thing in here. It's using the Cloudera machine learning capability. And this sort of shows that you can just tie these different tools together in a really easy way. So we've got our NiFi flow here. It's talking out to that model endpoint. You can see it's already got answers. Let's first go and see if my my tweets are considered to be suitably positive about the corporate product. Let's go have a look. Apparently, it is a positive message. Isn't that great? So let's go see what that's doing. So if I head back over to my main environment here, let's go and look at the machine learning environment. Loading that up. So this is the one that's attached to that DIM Amazon environment. There's other ones running in Azure, but this one's on Amazon. This is our Insights team's environment. They've got a pretty simple project here. which is doing some sentiment analysis. Now, I won't go into all the details of the project, but it's shared. The whole team can work on it. That's all fine. The main thing that it's done is it trains on a set of similar sorts of data using a Python model, and then we publish that model out for other systems to use. So if we go and look at that model publication, it gives you a test case here. It gives you a key, which allows you to access it securely, gives you the FQDN that it's on and that sort of thing. So what we've really done here is we've taken that data and we've plugged that into NiFi. So if I plug my own message into this with the access key towards the model endpoint, I get that response. So going back into my NiFi flow and looking in here, then I can see I'm just calling the model host. That's another parameter I've set up in the model endpoint with my data and getting the response and processing it. So it's really simple. I know I went through that quickly, but that's just a really simple interaction between one tool to another tool using the shared context to provide all those capabilities to integrate the different tools. So let's take our data. Let's check that we succeeded. We'll prepare ourselves a nice JSON message from the outputs. And then we're going to send that back to our marketing team. So in this case, we're going to publish those scored quotes back to another shared topic, which are Insights Kafka brokers. So this is to our local Kafka environment, so the Insights team. So they're publishing it ready for another team to collect. That's another very common model with this sort of thing as well. The team that has done the processing publishes the topic as a shared topic, and then somebody else comes in and collects it when they've got permissions to do so. So they published it to a topic under a parameter called Insights Scored Tweets. We'll go have a look at that. So in our parameter context, the name of that topic is Insights Scored Tweets, Shared Scored Tweets. That's on their local Kafka cluster, ready for somebody else to work on. Let's go and have a look at that. So we'll go back to our Data Hub cluster. We'll go back into our local Insights teams environment on Amazon. Oh, that's the data processing one. That's for the data warehousing work. Let's go to the data flow one. There we go. And if we look inside our Kafka manager on this environment, on the Insights environment, we can then go and look to see what topics they've shared out. And we shared that shared tweets. There it is. So that's the data that they're sending back again. We can inspect that to see this tweet from me that I've been reprocessing. See the output is quite nice. And this is looking directly at the Kafka as well. This is a quick inspection method that's part of the monitoring tool. So we can see that it thought my tweet was positive. It's not particularly confident that it's positive, but it's apparently positive. So we're all right with that. Now we've shared data from the marketing team to the Insights team. Now we might want to send it back again. So if we go and look at our marketing team again, they can do exactly the same trick that our Insights team did. So here I have another Kafka consumer. I've pointed it, and you'll be familiar with this by now. I've pointed at the Insights team's Kafka environment, told it to pick up that topic with the appropriate security context. And if we run that, we should see our data come across as soon as it's authenticated and pull the information in. Now that's all well and good, I suspect you say. It's using a bit of NiFi and it's doing its thing. Let's go and look at, here we go, there's all the results from my testing today. Let's consider we talked about a third group, which was our IT security group, which was going to be worrying about all of this and making sure it all worked and that nobody was doing anything dodgy. So actually what we can do is on that classic cluster, they've been sitting here the whole time, I'm going to tell you, and they have been automatically monitoring that anyway, despite me having gone and created all that stuff. So we can go in here, we can jump into their environment. This is a very simple classic cluster. This would be my half a cloud here. I think I'll get around to making a very big fancy one. It's going to complain my password is bad. So this is running all of the traditional Cloudera services, lots of bits and pieces here. The thing we're particularly interested in is that there's a streams replication manager running, which is sitting here. And I've actually instructed it to look for any topics called shared, essentially, because that's the one we know people are allowed to pass data between systems on. So in this term, this streams replication manager is reporting into a local Kafka monitor as well. So let me go and deal with that. If I pull that up, just a moment. Oh, there's the one we want. So this one here. Now, if I search in here for shared, what this is doing is you will see that there's the shared topic from the Azure team, which is the marketing team, and then there's the shared topics from the insights team as well. And what the IT security team here is doing is they're pulling exact duplicates of those topics down using Streams Replication Manager. We can see the replications running here in the background. Again, this is all just automatically set up. We can view the information about those replications, the topics that it's collecting. You'll see here Simpsons quotes. That's my test data set, because we should not use live customer data in environments. And that's running in the background. So anytime anybody adds a new shared topic on either of those environments that are sharing data, the system here is just going to automatically grab a copy of that and pull it down to our security cluster so we can keep an eye on it and keep a track on it. Now, that's not the only reason you would use something like Streams Replication Manager on Kafka, but if you do want an exact copy of something, that's a pretty strong way to do it. So these are our teams. Our teams have shared data back and forth. They've used pretty simple security context through the environment. The other thing I'd say about all of this is it's all automated. So there's a couple of steps in here. Obviously, I've been using the GUI to show you today, but this environment is automatically deployed using Ansible, wrapped around the CDP CLI as a collection that we've been working on for a while in our automations team, which I help run. And we're hoping to publish that out pretty soon. So that's what we've got. Hope that was interesting, with 2.5 clouds, data streaming back and forth between them, and the IT team, as always, taking a copy of anything they want because they are in charge. And I think I will come back to you, Anna. Yeah, so let's bring Anna back in as well, I think, and we'll see if there are any questions while I was talking about that, or if we're going to bring Tim in next.
Hello. Thank you very much, Dan. That was great. I think, we now understand what he means by 2.5 clouds. Dan's mind doesn't always work like us normal humans or us mere mortals. So yeah, I think that was really interesting to see how CDP really makes it super easy to have, multiple environments running in different clouds, same technology, absolutely seamlessly. So pretty exciting there. So next we have Tim Span, who is a legend amongst men as well. He will be showing us some really great technology from, again, a little bit of NiFi, a little bit of Kafka, but also Apache Flink, which is one of the hot new kids on the block in the streaming space. So whilst Dan is going to be a pretty hard act to follow, I don't think Tim is going to have too much trouble wowing us. So if we bring Tim back on, who's going to be joining us from across the pond. He's our honorary American today.
Greetings from the colonies. I'll hop into my presentation right away. Hopefully you can understand me. I'll be sharing first a quick presentation, then we'll go into a demo. I know we don't have a ton of time here, but I wanted to first mention we have another event coming up next month. I don't know what time zone that'll translate to you, but it's not probably similar time to what it is now, maybe a little earlier. And I was going to do a demo with Twitter, but my boss stole it, so we won't do that one. But as you saw in the tweets out there, there was a comment, it's not Franz Kafka, was a brilliant writer. But it is Kafka. We're going to talk about Kafka a little bit. That's me at the Kafka Museum wearing a Kafka shirt. And here comes the confusion. Kafka, the streaming engine, versus Kafka, the writer. Either way, I wish I was in Prague. But I know you've seen Kafka before. I just want to show you a little bit about it because we're going to put data into Kafka and we're going to query it as if it was a database. But it's not a database. It's a stream of live events. And they can be anything, as we saw, from Twitter messages to weather data, sensor readings, whatever we may have. This is a very simple use case. I've got weather data coming in from the U.S. Weather Service. You could also pull that up from a number of other providers of weather data, as well as your own local sensors. You can get weather sensors. Also picking up some pollution data. Not doing too much with it, but we'll bring it in with NiFi. I'm going to store it in Kudu so I could do very easy analytics with Impala, do things like visual apps and dashboards, show you tables. That's what people are familiar with, but we're also going to be using that data live within Flink. And I'll show you a simple way I can use SQL that anyone knows how to use. And that can be spun up with an awesome Ansible script by Dan in 2.5, 3.5, 9.5 environments, whatever you have. And then we'll show you that live. We don't have a fancy web UI for Flink SQL yet. We did buy a company, Aventador, so look for that coming. But we'll show you how to do that in a very simple manner. I don't want to show you too many slides. I know we don't have a lot of time. But I'll make sure everyone gets these slides so they can look into what exactly we're showing you. But I want to show you a live environment and not a bunch of slides. We'll share these off, put them in SlideShare, and make sure you could get to them. But let's start at the beginning. I wanted to get weather data because I want to know if it's raining outside, and what's the weather in the entirety of the United States. So if you were writing this by hand, this could be complex. This could be difficult. It's not in NiFi. So I'm doing a REST call to a U.S. government site and grabbing a zip file. And I'm downloading that zip file, unzipping it, taking out all the individual XML files. Yes, I said XML, everyone's favorite. And then I'm checking it to see if it's one of the sites associated with an airport. Those tend to be in the US at places where, the data is more interesting. It also gets rid of some of the weird locations that are in swamps or offshore. United States has a lot of semi-livable areas, so we're going to avoid them. And then in the next step, we're going to do something very easy. We're going to take that XML, convert it into JSON with a little SQL query here. Again, if you know SQL, you're going to be very happy doing streaming apps. So I just want to make sure it's not some weird location. I get the data in. It's now in a readable JSON format. I'm going to run a validate on it. Some of the records aren't going to be valid against the schema that I want to use because some of them have some malformed data or the data was broken. I'm going to put them in a holding pattern. I could push this to an S3 bucket. I could put it in a file system or I could throw it away. Right now, I'm just holding it. And then I'm going to push this data to Kafka. This is not to a book. This is going to our streaming Kafka running in Amazon. And we could take a look to see if that's showing up. So we'll go here and we could see there's a topic called weather. This is where our weather data is going. And we could see a number of records are coming in. Got over 5,000 records. This is nice. One thing you'll notice is when I pushed the data here, I pushed it as, if we'll see here, it's Avro. Avro is an open source format that's binary, but has a schema associated with it. It's a nice format for transmitting data, but it's not always human readable. So fortunately, using our SMM that Dan mentioned, I can see that data in a legible format because it understands what the schema is, what the version of the schema is, and how they're connected. So it can translate that data to me real time. This is helpful if you're trying to find where did my message go, because we could potentially have 100 partitions. This is running on multiple servers. How do you know where a message is? I can find the offset and then see it and go, okay, that message came through. Very important for debugging. So we have this data. This does not look like a table. This is a streaming queue of data, but it doesn't mean I can't do SQL against it, which is very powerful. I could also do, while I'm in this environment, we could do other things like monitor the servers, see what's going on with topics over time. I could look at who's producing data. I could see who's consuming data, which is important to say, oh, this person's not writing it very quickly. I can look at my Kafka Connect apps. I've got one for weather. It's pretty straightforward. It takes anything from that weather topic and drops it in an HDFS directory. This is the entirety of the app. I have this in a GitHub. So if you're interested in writing weather data to HDFS, you can do that. I also have set up alert policies. I've done that in the spirit of Dan's DevOps. I have a script that calls through REST endpoints and builds these alerts for you. So you can build up your own alerts. They're very easy to read, and they're things like, there's no consumers reading it, cluster's not replicating, my producer's not active, the latency is going up above a certain level, something's offline, things you care about. And then for a notification for each of these alerts, it shows up in this tool, but I also send it to a REST endpoint that happens to be NiFi, because if I can do something with NiFi, as people will tell you, I will do that. So I did mention we want to look at Flink. So you'll see this fabulous environment for Flink. Now this is a helper environment. So this isn't where you'd be doing too much in production. Maybe you do an ad hoc query. Maybe you prototype your queries. But once you have a query that you want deployed, you don't need to use this tool. So we're going to pick a catalog. A catalog defines different things that I can query. As you might imagine, you can see there's one for Hive, one for Kudu. I'm going to do one for this registry. Now, when we look at this list, it's going to look familiar because that is our schema registry right here. So you see one for weather New Jersey, one for weather. Pretty easy to do. Beneath the covers, there's a full Swagger documented REST API. So again, if you want to automate building your schemas, which I do with a shell script, it's very easy to do. So we have these topics that define my data. Now my data, when I'm using the catalog for schema registry in our Flink SQL here, is using that registry and then pointing to the associated Kafka topic. So it'll be able to know what this data is supposed to look like. So if I describe, say, weather, this is going to tell me what the fields are, what the names are. I'm also going to describe this other table or topic I have here, weather New Jersey. So I decided to write an app while Dan was talking, because I've heard his talks before. They're really cool, but he does all the DevOps for me, so I don't have to do that. So that's very nice for me. Not nice for other teams, but for me, I go, Dan, I need this thing, and he automates that. So I wrote a very complex streaming application that could span, hundreds of nodes, thousands of nodes with Flink. In mine, it's just one because we got to save money in the cloud here. So if you look at the top here, this is not the title of my application. That is my application. It's also the title, but that's the entire application. I could fit that into a tweet. And this is SQL. Doesn't look anything specific, but this is a full streaming application. This is where the power comes in. And this doesn't require that Flink SQL runtime to be running. I could just run this SQL as a script, and it'll deploy it as an application here, which you can monitor with the global dashboard. And the application is this: insert into weather New Jersey. What is that? We look here. Here's the topic. This topic points to this Kafka topic. So this is my source of data. This is also, in this case, the destination of data. So I'm going to insert into that topic using that schema. I'm doing a select. So I'm going to select a couple of fields from weather, which if we looked is another Kafka topic that has some data. I think you're starting to get the idea here. I'm checking it where the location isn't null. I could have done as many in the where clause as I want. I could have some aggregates in there. I could do things like look over tumbling averages, group bys. It could get extremely complex. But for this endpoint, really I wanted to do is select a subset. And I forgot one part of this, which I should have taken a look at, is I should change this where clause to add where location like New Jersey, or since I did call that New Jersey. So that's a thing I have to change, but it's not hard to change. So you see this running, it's loading data into another topic based on that. So that's an application that you could do some easy functionality there, like doing aggregates. Like here, I'm doing a subset of the data. Like in his example, maybe marketing only cares about tweets that are coming from the United States, from non-Clouderans, and it's Tuesday. Those sort of things you could do, and I could set up a topic to do that, and it's a simple SQL to do it, and then they'll have that running. So if I'm developing an application, I could just start playing with it. I don't know what these locations look like. I should probably take a look at the weather data and see what that looks like so I could do a query. So take a look and say, well, what does that field look like? Oh, it's not an integer. Pick your type. No, it's not a long. Arrow. Click properly, people. We'll help you. So we can look here and see how we have location in here. I could also take a look in. I have this stored in Kudu for this data, and I could see they abbreviate U.S. states. So the abbreviation for New Jersey is NJ. So I'm going to search where a location ends in NJ. Very easy. Now, how did that data get in there? Let me show you that real quick before I gloss over that. It's very complex in NiFi to write to Kudu from Kafka. It's a very difficult, long application. I don't know if you want to see it because it's so many steps involved. You know, you'll get lost while we do it. And you're like, why'd you show me this complex app, Tim? And I'm going to show it to you. Okay, it's these two steps. It's actually really easy. I pick a topic, and then I write it to a table. I don't need to know the fields. I don't need to know much of anything. Pretty much anybody could write that. Okay, so I'm going to do location like NJ. I think it was capitalized. Let's see if this query works. If it works, then I could update that insert and make a new application based on that. So I see some New Jersey ones. So that seems to be working. If you look now, I've already got 3 pages of that data. And that's the ones that are coming in currently. So that's nice. So I should change my application to use that query and not the fake one here. So since I'm a administrative user, I could cancel that old job. And now that job's not running. And since I don't want to set up a deployment script, I can deploy that right from this application. Pasted that wrong. Okay, so I'm going to deploy that as a new application. As you see, it deployed that to my Flink cluster, and now it's live. I could see that starting up here, just started running. So I just changed our Kafka application, pretty much real time. Hopefully I didn't screw it up. We could take a look and see what's going into that Kafka topic, and we'll see if we're starting to get data. Hopefully we did that correctly. We should have some of that old data in there still where it had non-New Jersey sites. But if you see here, we've got the New Jersey one starting to show up, Linden Airport, McGuire Air Force Base, which is about a third of my state here, and Mount Holly. So that's New Jersey. So we see we fixed our app. We're starting to get data in. You just saw a live Flink SQL application developed that's useful for me. So if I needed to segment data any certain way, now it's going to Kafka. From Kafka, I could push it somewhere else. Flink could also push it to other data stores, not just Kafka. I can push it right to Kudu. I can push it to HBase, S3 bucket. There's lots of different things. Once I have a schema defined and I have it in a Kafka topic, the world is my oyster. I could do so many different things with it. I could have another Flink app, read it. I could have a NiFi app. I could have a Spark app, Kafka Streams app. We saw a Kafka Connect app doing it. I could do it with things like Spring Boot, or I could do that maybe in a machine learning model. Very straightforward to do. I don't have a really nice visual app for this, but it shows a little bit. I've got, as the weather data is coming in, I got a little map. Right now, this is connected to the Kudu table, and it's not connected live to Flink SQL. That is on the roadmap, and that'll be pretty exciting. But for things like this data, which only comes in every 15 seconds, it's fine for me to be using something out of Kudu. You don't really update your weather forecast every second like you might do with some other data sources. We can look at the weather right by me, which is the closest one. Is over here at the airport in Ewing. I get the average temperature because I'm reading multiple rows for these, because I get a new report every 15 minutes or so, depending on the airport. So we could push that data out for visualization really easy. We have it stored, but if you want to write new applications, it's really simple. That's the main part of my talk. I don't know how easy it is if someone could feed me any questions on this. Otherwise, I could show you how I integrated CML and some other machine learning and deep learning in the process. Not sure how I would see the comments there. Before, I was looking into the LinkedIn page looking for questions. When we do the meetups here virtually in Princeton, Philly, and New York, we usually do it through Zoom, so I could see people and they could say, hey, what about this? Anyone think they have, is there any questions? Can someone feed them to me, maybe through our team chat, if there's any questions? Or do we want to go into the open discussion part? Otherwise, I'll just show you other pieces of the app. But if people have questions, I definitely want to show you how to do this. This is all in my Apache Con home, because this is based on some demos I did at the recent Apache Con event. Okay, so we're going to go through some questions. Hopefully we have a couple. I know sometimes at meetups, people kind of don't want to talk about it or don't think their question is interesting. It's interesting because clearly we haven't thought of it. So it's nice to have comments from people. As you see here, I'm writing, updating my code real time here. That's my whole Flink SQL app. Okay, I got to stop sharing and then we could do that. There we go.
Okay, I think the three of us are live on screen. Hello, lads.
Hello.
That was brilliant, Tim. Thank you. I'm also really, really glad that like other people exploit Dan's obsession with DevOps, because I thought it was just me and I felt really bad, but like, that's cool.
So much hassle. Tim's here throwing mad jokes at me when he's presenting, and I have absolutely no recourse. It's so unfair.
It is true.
It's awesome.
All this banter. No response.
We need to be able to somehow live heckle back. I don't know.
Yeah.
We'll think about that for the next time. So we've had a small handful of questions, which is good to see that some people have been engaged and or they really want the collection of swag that we're offering. So I think I'll just go through the questions one by one, and I'll keep an eye out in case there's other questions during the time. So guys, we're going to be talking for 10-15 minutes now. If you think of other questions about anything, add them to either the LinkedIn or the YouTube comment feeds, and really, really happy to get Dan and Tim to answer. So we have a question from YouTube from Magnus Runason. How do you version control things in NiFi and compare different revisions? Because obviously, it's a very easy to use tool. You can just make flows, do things really easily, but that's not really that safe in production. So what do we have there?
Yeah, so NiFi has that whole live edit capability, whereas most production environments are design and deploy, right? Once it's built and deployed, thou shalt not touch it lest they break production. So we don't want to do that. I can actually show it, but I'll talk about it first. So NiFi has a built-in registry which does version controls. It allows you to move forward and back between versions to compare them, so do diffs, that sort of thing. That can be accessed via the GUI, as we were looking at today, or you can hit it via the REST API. So NiFi, like most of the Apache projects we do, has a fully defined Swagger REST interface. One of my projects is to maintain the Python code for that, for the NiFi team. And there's some demos you can look at as well, which walk you through how to do that version control. You can also get fancy if you want to. So you can import and export versions. So doing code promotion, say from a staging to a prod environment, or thinking about the example we had today. Let me share that up. Yeah, quickly. Let me find it. Choose one of my screens. So this is the this is the Insight Teams environment on Amazon that we were looking at. And if we go here, you see the registries here and the NiFi flow is here. I've got the flow open. This particular one is in version control. So the idea of this is it's showing a green tick saying, hey, that's versioned and it's up to date. If I went in here and modified it, for argument's sake, I don't even have to do much to modify it. It tracks everything like position and everything else. It's going to say, hey, you've got uncommitted changes that you should worry about. Do you want to do something about that? So it's going to say here now, local changes have been made that are uncommitted, and they're not currently pushed into the registry. Here's our registry. Score sentiment for marketing is the application. There's one version. If we now say, hey, I want to commit that change I've made, do a commit message because I'm a good Boy Scout. So moved a processor. It's telling me it's going to be version 2. Save that. It's now showing me that it's up to date. We go back in here and look in registry and refresh this. We will have another version, which is, I know, not particularly exciting, but that's basically the deal. And then if this is the Python client I maintain called NiPy API, again, because I think I'm funny when I name things. This example here, FDLC, flow development lifecycle, will walk you through using Docker containers, creating a flow, versioning it, migrating it between environments, and putting it back again. So if you're interested in that sort of work, then go and give it a try. It's all open source. It's all free and easy to use, and that particular one builds inside Docker to make your life easier. So hopefully that helps answer Magnus's question. And if there are follow-ups to that, happy to take them as well. But then we can go back to hanging out with the team and having the mad bands.
I'm sure everybody was looking forward to that. Thank you, Dan. That was a really great explanation. Next question from Graham. How do you manage data sets for testing flows? I guess it's pretty easy when you have access to production data all the time. How can we do, kind of testing whilst we're developing our flows, and how do we manage those data sets?
So there's a lot of approaches. And Tim, tell me if you want to jump on this one instead. But the main one I use is I will commit sample data sets to a Git repo. Usually I have one repo with a bunch of different stuff in it for different sorts of purposes. And you might do the same thing for internal data at a customer, but often they'll have like an NFS mount they use somewhere for that sort of thing or whatever. The thing with a lot of streaming applications is we tend to either have a sink or a source be a table or a file system, but more common something like a Kafka topic. So what we were looking at today in both my demo and Tim's is we loaded up Kafka topics with data that was useful for the application. And then we just kept on replaying those topics for doing different sorts of things to try out stuff, make sure it's working properly, look for errors in behavior and that sort of thing. When you're getting into more production ready sort of services, then you'll be running a whole bunch of load, process, and test on completion, maybe in a scripted way. So I often use Python because that's my preferred language. We can do the same thing even with those NiFi flows. So you might say put 1,000 records in a Kafka topic, run your NiFi application. When it's finished, run a script that tests that the outputs were correct, and then carry on. Most of these tools can also automatically load that data for you. So NiFi will quite happily do that. Kafka Connect is popular for that, or Streams, or any of them really. You just need to decide what sort of data set you need, how big is it, does that impact your infrastructure? But yeah, my favorite lazy man's approach is I have this Git repo, I curl the data from it, and I throw it at Kafka topic, and off I go. Would you add to that, Tim? Anything different?
We can't hear you, Tim.
Tim, you are muted. You get -1 Zoom point.
There you go. So you could have, like you said, a CSV or JSON file in a directory and you'll load it up for testing. Another thing we do is we could use simulators, or there's a generator in NiFi. I wrote an article about it. Sometimes you use that and make it look just like your data. I mean, that's what we do in our workshop. And it's pretty easy to simulate data, especially if you know the schema. You make the data match that schema. And NiFi has some scripting that'll let you put it in a range. Also, sometimes I'll test it with something like Mockaroo or one of the free REST endpoints out there that'll let you design what you want your data to look like. And then you could just have it coming through. Or NiFi is great for, while you're developing, push it on the side and just put it into a file, and then later aggregate it and then just put it, like you said, in a Git repository, in an S3 bucket, or wherever you want to keep your data. Or, you know, if you have some kind of data set management you want to do, there's a lot of development tools that could be used for that. Or one of those tools that builds up databases. You know, you could use one of those automated data populators for populating, say, a MySQL Maria database or Postgres, full that, and then just pull it out of there. However you do it for other tools, all those techniques will work, because it doesn't really matter to NiFi. Then once we get it into the stream, easy to do. It's not like it's complex to set up these testing. There's also ways to test your processors through command line executions of them, or if you want to do integration tests, if you wrote your own custom NiFi processor. Or your Dan could script up the whole thing with Ansible and some crazy DevOps. Test it, put it away.
Maybe.
There are mocks for Kafka out there. So if you want to use that, you could search on that if you wanted to use a mock Kafka for some reason.
All right, sounds like a lot of ideas. Thanks, lads. So we've got another question from Sebastien. What is the impact on the architecture if one of the instances, for example, in Dan's multi-cloud scenario, what's the impact on the architecture if one of those instances is not using CDP?
Oh, it's not too bad, actually. So CDP makes a lot of that stuff easier in the instances of the cloud environments. So we provide things like proxying from your ID broker to the IAM on the cloud to handle permissions and stuff like that. So you might have a user account, and obviously the way that permissions are done on Azure versus Amazon are quite different. So we handle sort of proxying that and making sure that works properly. If you weren't using CDP, though, you can still permission stuff in and just go for it. So you could either direct access if you wanted to, but it might be easier to do something like get NiFi to do that for you, because it's got sort of hundreds of connectors for talking to different services and different systems. So say you were using Azure Event Hubs, or some team was using Azure Event Hubs, but you're using Kafka. So you could use NiFi to read from Kafka and write to Event Hubs or pull data back again. I've done triple cloud between Google PubSub, Kinesis on AWS, and Event Hubs in Microsoft, and then pulled that all back into Kafka on CDP. That totally works too. They all behave slightly differently, but NiFi sort of just handles that for you. The other thing is that part of the big deal with the open source and the Apache stuff that we pull together into this is it's very interoperable. So we were looking at SRM earlier for doing Kafka replication. That uses MirrorMaker 2, which we contributed back to Apache. And MirrorMaker 2 will basically talk to any version of Kafka Connect that behaves reasonably. So all the open source ones, the Amazon one, the Confluent one, any of them, doesn't really care as long as it's running Kafka Connect, right? So we quite happily go, oh, well, I need data in that Kafka server. I don't care what version of Kafka it is. I just want the data. And so we can just go and do that because of the interoperability around all these systems. So yeah, it doesn't have to be running CDP. Obviously, we make it easier if you are running CDP, but if you're running multiple distributions or using some native cloud services, or you've got some homebrewed stuff you're doing, it'll probably work. And all you probably need is authentication, authorization, and TLS termination, and off you go.
It's as easy as that, folks. Always with the automation.
If you pay Dan to do it.
Yes. Dan can be bribed very easily
with whiskey,
with whiskey and fancy beers. So just FYI. Yeah, great. I guess that's the advantage of using open APIs, open standards. It's a good time. So we have a question about whether we actually provide Flink training, prompted by Tim's great demonstration there. The best place to actually look for that is on the Cloudera website. We have a page that lists the current and upcoming trainings that we have and what's available either for free or on our paid on-demand library. So definitely encourage you to go there. The training catalog is evolving all the time. So probably I think there's one about Flink coming pretty soon. Any tips, guys, on how to get started with it? You know, any online tutorials, any kind of places that are pretty good in the interim?
Yes. Cloudera has a GitHub for Flink tutorials. If you go to GitHub, Cloudera Flink tutorials, I think there's a dash in there. There's some really good ones that Martin and our team put together. They're very straightforward and cover stateful, stateless, SQL, security. It's really nice. There's also a good amount of documentation on docs.cloudera.com. There's also, I just did a talk at Flink Forward, and so did some other people. The Flink Forward content is free, and there's a bunch of it there. That's helpful. I've got a couple of articles at my website, mostly covering the Flink SQL part, because that seems to be lower hanging fruit. Flink apps themselves are, about as complex as Spark. So you have to know, you have to have a language, set up a build environment and deployment, and understand your connectors and the right Maven repositories, and that's a little bit more complex than typing Flink SQL start and select star.
Great. So hopefully we can link the GitHub repo in the comments on either of the platforms that we're streaming on now. So that sounds like a great place to start. So we've got kind of, I guess it's a bit more of a philosophical discussion from your fellow Antipodean, Dan Hall, who's hailing from Oz right now. He's asking, kind of when initially we set up Cloudera stream processing and CDP, Are there many one-time decisions that need to be made, that you can't defer, things that can't be changed later? How much do you need to decide up front before, getting started?
Yeah, interesting. I think there probably are a lot of architectural decisions that you want to be careful about. I think that we used to say, one of the lines we used to have was data has gravity. And I think that's still true in that once you start building up, particularly streaming applications, once those data sets start building up, you've got your Kafka brokers in place. Moving them gets to be annoying because people have started to rely on them. And while you might have an SLA around a batch job of 24 hours, once those streaming applications get heavily in use, people are like, oh, well, it should have updated in the last 5 minutes. Why hasn't it? People sort of get impatient, right? So I think it does change a little bit in that thing. One-off decisions, though, one-time decisions. Certainly, I would advise people to go for distributions and security models that have good accessibility to them and good communities around them that you can access. And I don't just mean, hey, go use CDP. I also mean, well, consider where you want to innovate on the platform. Are you trying to innovate around the operating system, or should you use an OS that is, big in your area? So I wouldn't recommend in Australia that you choose SLES, for example, because it's primarily in Europe. Probably CentOS 7. It seems like a basic decision, but a lot of companies do go ahead and go pick up something fancy because somebody likes it. And I think that works all the way up the stack, looking at the databases you use, looking at distributions, but also cloud platforms. I see a lot of companies, and part of the reason I put this in the demo example of having different teams decide to be on different cloud vendors is because companies do that, right? You've got like the marketing team who's over here doing their own thing, and then they haven't spoken to the ML team who are already on AWS, thank you very much. And they're not speaking to the operations team who do everything on Google. So if you can, try and ask those questions before you deploy, because once you're on there, you don't tend to come off. And I realize I'm laughing about this, but the number of customers who have done this and the number
You're
of
laughing because otherwise you'd cry.
It's making my automation work exactly the same on 3 cloud platforms is basically what CDP is about, right? And if that's a one-time decision that you can make, but even then, hybrid cloud, there's a lot of companies who are saying, well, we cannot be beholden to only one vendor, one cloud vendor. What if they go down? What if Microsoft forgets to renew a certificate again? What if Amazon kills off a region again? What if Google does that as well? Yeah, it's a very difficult balance between getting started, not spending too much time thinking and testing and trying, getting something done, but also recognizing that once you scale it, you might have to scale out and up and across into other environments in order to meet dependencies. So yeah, philosophically, I have lots of ideas about that, but then I'm also come from banking where we spend a lot of money on getting everything right eventually.
Sounds good. So this is quite a nice one. I think maybe, Tim, you can weigh in on this. We've got a question from Alex about when should we use Flink as opposed to other streaming technologies such as Kafka Streams or, a DIY Kafka client producer, or I don't know, what else have we got? Spark Streaming or whatever.
NiFi. Yeah, we have a nice paper on that. And we also have done some talks, but in a nutshell, it usually comes down to do the simplest thing that'll work first. Usually that's NiFi, because NiFi is graphical environment. See if NiFi will do it. Because some people think, I have this massive streaming problem, and it's only, 100,000 records a second. Or it's, 1 million rows a day. Or someone told me, I've got 1 million rows. I'm like, okay, how many, is that a second? They're like, no, a day. I'm like, do that on Excel. So you start off simple. NiFi, if NiFi can do it, it's easy, fast, and does what you want. If it looks like you need to do something that's Kafka only, and it's something like, I want to take it out of a Kafka topic, put it in another Kafka topic, and do maybe some kind of Java calculation in the middle. That might be Kafka Streams, might be Flink. Kafka Streams is real nice if I stay between two topics. The same thing with Kafka Connect. If it's something like pick it up, put it somewhere, it's hard to say if you do NiFi or Kafka Connect. If you have a lot of Spark people and they want to do streaming, but they still, they know the batch part, they know the SQL part, maybe they're doing some Spark ML, maybe you stay with Spark streaming. It's nice. The only trade-off is it's still microbatch, so that's not exactly streaming. You come to Flink when if you want to do something with SQL against Kafka topics, event at a time, you want to do ultra fast, really low latency, not microbatch, real streaming. If you have something like windows of time you're dealing with, like I want to see the aggregates of an event stream over minute windows or 3-minute windows, and I'm doing these complex things. If it's something really complex on multiple streams of data, you're probably doing Flink. If it's something that you could do with Flink SQL, obviously it makes it a lot easier app. Other applications, maybe you're using Kafka topics in a front end. Maybe that's just a Java app. There's no wrong answer until you start hitting problems, and then you say, oh, maybe I should do the other thing. But the rule of thumb is if it's simple, NiFi. If it's Kafka only, maybe use one of Kafka Streams or Kafka Connect. If you've already started using Spark, or it's fast batch or micro batch, or doesn't really need complex event processing, maybe stay with Spark streaming, structured streaming. Use the Spark structured streaming, not the older one. And if it has more requirements than that, as windowing, aggregates, or you have to do some funky logic or SQL, go to Flink.
I'd also add to that, if you need to set up DR for that application, so if you're worried about replayability, moving that application between sites, you're not necessarily running active, then Flink has a lot more modern features around DR, restarts, checkpoints, statefulness that Kafka and Spark don't offer out of the box. Doesn't mean you can't do them with Kafka and Spark, but you're going to be writing a bunch of your own system level code to make that happen reliably. Whereas Flink, it's just like one line that says, hey, make this checkpoint and then put it over here and then restore it. Kind of like sharing a save game from Mario. Not that you guys remember that. I'm too old.
Dude, my video games are Pong, man. I'm Pong era, man.
Oh, right. I'm sorry.
Look how old my clothes are. I mean, I'm old here.
I wouldn't know. I just play Candy Crush. I'm from the mobile gaming generation. I've never opened Candy Crush in my life. But
a Commodore PET.
Did you know that Candy Crush is a Flink application?
Is it? I did not even know that.
Yeah,
that's amazing.
King run a massive Flink backend for handling all of the user stuff and interactions and how that system works. I think they run terabytes of state in Flink. So when you go and play Candy Crush, you are using one of the most advanced stream processing open source engines on the planet to eat candy.
I don't know what you're actually doing. I think you like crush candy.
You push butane, make candy. Yeah, no.
Yeah, I don't know. I think you get rid of candy. I don't think you eat it anyway.
Yeah. This is a tangent.
It's fine, but great, actually. Interesting segue that I didn't even plan. So I think that's actually all we have time for in the questions. I think that there's been quite a few questions, and I think a couple of people, have asked a bunch. So really, thank you so much for the engagement. Maybe, we can get to them in the comments afterwards. We'll see if we can manage to reply later on. But if you've prompted some good content with those questions, maybe we'll do it in a follow-up meetup as well. So thank you very, very much. So we're going to now head to the moment we've all been waiting for. And I wish I had a drum roll for this, but unfortunately, the technology gods have not gifted me with any licenses to do a to show licensed music. But just to give you a reminder of what is at stake today, 2 very lucky question askers from our enthusiastic audience will be in with a chance to win one of these things. So just imagine a drum roll in your head. That's probably it. I've put a list of names here in this very sophisticated, very random name picker. And the first person will win the first prize, and the second person will win the second prize. It's very, very complex. The only thing is, because it is a virtual meetup, we're going to need to get your contact details so that we can send you the lovely prizes. So if you are one of the 2 winners, please just hold on for a second so that we can message you. If you're from LinkedIn, we'll just send you a private message, so look out for that from us. Or if you're on YouTube, we'll give you an email address that you need to email us that you're the guy. We'll probably ask for, I don't think we can ask for evidence, but anyway, I'll send you an email address. So now we're going to pick prize number 1. And Chakra is the winner. Congratulations, Chakra. Oh, no, so it's not, sorry. Terrible. It is Sebastian is the winner of our first prize. So thank you very much, Sebastian, for asking your question. You're going to be the winner of this lovely duffel bag and hoodie set. Just hold on LinkedIn for a moment. You'll get a message from us very shortly. And the second name, hopefully I won't mess it up this time. Get rid of this. We'll pick another random name, if it works. And the second winner is Marek. Congratulations, Marek. You will also be the winner of this second prize with a lovely t-shirt, a couple of t-shirts, a tote bag, and actually I have that same JBL clip speaker. It's really good. And it's also waterproof, so if you want to sing in the shower, you can do that. And that is it from us today. So thank you very, very much, Tim. Thank you very much, Dan, for your wonderful content and for sharing your wisdom with us today. What you are seeing on your screen now is the date and a link of the next meetup that we're going to be hosting at Cloudera. It's going to be different time zones, so you get some different speakers here as well. But that is, I think, it from us in London and New Jersey. And have a good afternoon, morning, evening, wherever you may be sitting. And see you next time.